Now tell me what will it print? When I print this output, what will be the values of x which I will be getting? Can you just take a guess, guys? See, first of all, I will take the value of 0. It will print x. Then it will increment x by 1, which is now x equal to 2. And then I has taken already 0, so I will take 1 now. Then it will print x, which was 2. Then it will increment x again, right? So it will print 1 2 3 4 5. Now it is important whether it will print 6 or not. So it will not print 6 because, as I told, in Python it will always exclude the last number. So it will exclude this 5. So how many times it will enter into the loop? I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, right? So for I equal to 5, it will not go into the loop. Okay. So now if I run this, so it's printing only 1 2 3 4 5, right? Making sense? Now, see, it's important that for loop also we should maintain this indentation, this gap. Okay. Now tell me, what will this print? Will it print I? It will print 0 1 2 3 4. Yes, because I is taking the value from 0 to 5, excluding 5, right? Okay, now to clarify this, if I write inside quotes, then it will print I. Check this. Then it is printing I 5 times, right? Because here I is a character, it's a string. Okay, based on this I value, it is entering into this loop 5 times, and then it is printing I 5 times because it is into double quotes. So every time you want to mention any character or string in Python, it should be in double quotes. Whenever you are not mentioning in the double quotes, then it will assume it as a variable, or it will assume it as a number or some mathematical calculation. Okay, did I clear your question? Making sense? So it is printing I several times. For example, if I write say xyz, if I write say x, it will not print the value of x here, it will print x 5 times. If I remove this double quotes, then it will print 1 for 5 times because it is entering into the loop 5 times, because we are excluding this 5 here, right? Always remember this. This is the basics of Python. Okay, it will always exclude the last number, and all the conditional loop, for loop will end with double calling. And after that, if you want to write anything inside that loop, then you should always give that indentation. Okay, great. Now, for example, do you remember from yesterday's class, what is this? I asterisk asterisk 2. What does this represent? I square. So what will be the value now? Tell me, guys. It will be 214. You forgot 0. I is starting from 0, no? Right. So 0, 1, 4, 9, 16. So 0 is, this 0 is 0 square. This 1 is 1 square. This 4 is 2 square. This 9 is 3 square. 16 is 4 square. So this kind of coding is required. You don't have to worry much. And now if you want to combine this value with the string, for example, if I want to have a good structure here, then I should do something like this. Square values are equal to this. Okay. Now what will it print? It will give square value is equal to 0, square value equal to 1, square value equal to this. Okay, making sense? Now, for example, if you want to write this in a even better way, for example, square of this is this, square of this is this, square of this is this, right? Then the better way is square of, this is a string, right? Of what? I. So we should write, we have to separate that string with normal variable I. So the way we do that in Python is separate that with plus. First, let me tell you what is this plus doing for numerical numbers. For numbers, we know how does plus work, right? For string, how does it work? I'll just show you. Say square of cube of, okay? Now check this, what it is printing. Square of cube of, square of cube of, square of cube of. So what is this plus doing between the strings? This plus is concatenating the strings, right? So now you understood, right? If there is a string, then it will concatenate. If there are numbers, then it will add. Concatenation means adding, but characters cannot be added, so they can just join, right? So that is the reason we have something like this. So similarly, what I was telling, square of I, right? So I should write like this. Now I should not be in quotes because I should be the variable, right? Is I square. Now if you notice, this will give you better representation. Okay, so what it is saying, this cannot concatenate. So what it is saying, that we cannot concatenate here the character, the string and the integer, right? So what we should do, so we have to convert this I into string. How do we do that? Just write string of I, but we are not putting quotation on I, right? So it will still be considered I as a variable. We are forcefully converting this as string so that it can concatenate, because only strings can be concatenated and integers can, or numbers can be added up, right? The combination will not work. So I'm just converting everything into string. So now if you notice, square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, right? If you want to give space, then you can further give space here. You can give space here. You have to give space inside quotation because the space is also considered as a string, right? So now we have got a better representation, right? Making sense? Great. So now, guys, it's important that you should go back and keep working on coding. Do some simple coding. It's important that you keep on working on coding because, see, you will start loving it. I'm pretty sure that you will start loving coding. I'm also coming from mechanical engineer. I have started loving coding. You will also start loving coding. Okay, so you don't have to worry anything about it. Just it's just that you have to practice, dedicate some time. Okay, so now to do some fun projects now. Okay, now let's combine for and if loop. Okay, let's combine for and if loop. If I is divided by, so divided means if the remainder, say when I is divided by 2 and the remainder is say 0, the remainder is represented by percentile. Okay, then so you notice that there is one more indentation because this print is inside if and this if is inside for loop. Okay, print I is an even number, else print I is odd number. So now first I will take 0, right? I will take start with 0 and then it will continue till 4, right? So let's see what it happens. So if you notice, it is giving, okay, so I think it's the remainder thing. If I could recollect properly, okay, it's not I here, okay, it's I've written 1. Okay, let me correct that. Okay, now if you notice, because 0 is divided by 2, right, the remainder will be 0. That's the reason 0 is an even number, and then comes 1, which is odd number, then comes 2, which is even number, then comes 3, which is odd number, then comes 4, which is even number. So if you want to write it in a further better way, then what you should do, you should write I, and then you should first write string of I and then plus, because you have to concatenate this, right? So now if you notice, it is saying 0 is an even number, 1 is an odd number, 2 is an even number, 3 is an odd number, 4 is an even number. So it's so simple. It's just that you have to combine all the basics knowledge what we have learned. Try to do some simple coding here at your home. Try to look at some simple codes in Python, very simple, very basic codes on internet. Try to write on your own. Try to see if you're getting some error. If you're getting error, try to understand that error. Try to debug your code and then try to correct your code. Okay. So this is very important, right? Because coding is very important. Okay. So we don't need to close loops in like scene. Yeah, that's what I said. No, that's the beauty of Python. You don't have to close because the indentation itself tells that This is in for loop. This indentation tells that it is in for loop. This indentation tells that it is in for loop. This indentation tells it is in for loop. This indentation plus this indentation tells that this is in inside if loop and if is inside for loop. Okay. So the structure wise, if you look the code, it will look better structured when you compare to other coding language. No, it is more structured way. Okay. How to define a sample size? Okay. So there are different formulas, Naga. It's very important that you have asked this question, how to define a sample size, right? So for example, there are different ways by which you can define the sample. Okay, there are different ways by which you can define the samples. But to give you very one simple formula, we have say 1000 in the population, we have say 1000 data. Okay, now for example, for one particular component, you are putting the sensor probe points in 1000 different locations, and if you want to read that out of those 1000, if you want to read only say some of them, because you won't be having time, right, to read all the 1000 probe points what it is measuring. So in that case we will use sample size, right? So there are different ways. Again, the first way is how much error we can expect in our inferential statistics. That means once you take the sample, so just imagine in this simple way, very simple way, if I have 1000 population and if I take all the 1000 data for reading my calculation, then the error would be almost negligible to zero, almost negligible, right? It will be almost zero, right? Then if I make the sample size to be say 500, then I might get some accuracy for that model. The error would be like, let's say the error might be say 2%. Let's say that the error is 2%. When you are doing the inferential statistic, once you got the result from the sample of 500, you are inferring something about the population and the error what you got is say 2%. Now, when you take 100 samples, the error will increase or decrease? Increase, right? So it's everything. That's what I'm saying. This complete course, machine learning and AI, it's pretty simple. It's based on only math, coding and common sense. So it depends what is the error which is acceptable. So in general, there are different formulas, but anyways, I'll just write down one of the basic formulas, one of the simple formulas for sample size. So 1 by error square. Okay. So for example, if the error is say 10%, that means 0.1, right? So 1 by 0.1 whole square will be how much? 100, right? So with 10% of error, you need 100 samples. Now let's say you are working in a domain where you cannot accept 10% of error. Let's say if you want to have only 5% of error. So with 5%, what will be the value for 1 by 0.05 whole square? Will it be 250? 1 by 0.05 whole square. How much will it be? Will it be 2500? No, Raga, it will be, it's pretty straightforward, no? It's 400, right? Can you please check it? Let us calculate. Why is it so difficult? With 5%, say this is 5 by 100 whole square. So this will be 100 square by 5 square, which will be 10,000 by 25, which will be 400, no? Right? Making sense? So that's simple, no? So now you got the point, right? It's up to you what error you can accept in your analysis. And that will be given by your client. So you don't have to worry, that will be given by your client. And based on that, you have to extract the sample. Okay? Great. So now let's check this. Yesterday we have read about discrete random variable and continuous random variable, right? Now there are two types of distribution also. Discrete probability distribution and continuous probability distribution. Again, in this case, we will be doing a lot of interaction. Okay. So let me put this chat box here because we'll be doing a lot of interaction again. Okay. So that I can see what you are typing. Okay. So now discrete probability distribution and continuous probability distribution. For example, rolling say tossing a coin, right? Will it be the distribution what we will get tossing a single coin? Will it be a discrete probability distribution or continuous? Discrete, right? It's simple, no? Because either we can get heads or tails. So if I want to write probability distribution for heads and tails, the probability is say 1 by 2, 1 by 2 for both of them, right? So this is called as discrete probability distribution, and moreover it is called as uniform probability distribution. Why? Because the probability is same for both head and tails, right? Making sense? So in discrete you have uniform discrete probability distribution. Similarly, you will have Bernoulli and binomial discrete probability distribution, which I want you guys to read about it. Okay, now going to the continuous distribution, which I want to explain because this is quite complicated, which I want to explain. Okay, continuous probability distribution or continuous distribution is divided into two, which is uniform distribution and normal distribution. Okay, making sense? So for uniform means for every random variable, for every continuous random variable, you will have some probability associated with it, right? And for all it will be same. Okay, so it's pretty clear from this graph, the frequency for the different random variables has to be same, then it is called as uniform continuous probability distribution, right? Now what is normal distribution? This is very important, guys. What all we'll be dealing in our coming sessions will be based on normal distribution. So this is important. Remember this normal distribution. So I hope you all guys work in different organizations, or maybe you might be knowing about appraisals, right? Yeah. Do you know about appraisals? You all know about appraisals in the companies, different companies, right? How does that appraisal work? So for example, say this is, let me draw it once again. Say this is your normal distribution. Okay. Now this is your frequency or number of times it is appearing, and this is your random variable, right? Now appraisal will range, say for example, in appraisal in a particular company, say appraisal is ranging from say 5 to 20% of hike every year. Now what does this hike, this peak means? That means there is a very high frequency for this particular x values, right? That means in this range, if you notice, there will be, what will be the x value in this range? Say 10 to 15, 10 to 15%. So if you notice, there is high frequency for the people, or that means there are high number of people who are getting a hike between 10% to 15%, right? Because here there will be very less frequency. That means there will be very less people with 20% hike. There will be very less people with 5% hike also. Why? What can be the reason? If company gives high frequency for 20, if there are high number of people with 20% increment, then company would be in trouble, right? They have to always follow the normal distribution. That would be the relative, right? So they have to give the relative appraisal based on the performance. They will give this appraisal, right? They cannot give every member 20% hike. They cannot give every person 5% hike. And even they cannot give most of the people 20% hike and most of the people to with 5% of hike. It's simple. It's a simple tendency, right? So most of the people will get an average hike. And that's the reason in this average hike, there are most of the people falling in this, right? In this region, most of the people are falling. Clear? Making sense? So similarly, if you want to see, let's assume this is the temperature values. Say this is 0 degree for one particular component, or let's say I have different components of a vehicle. Say I have say some car, and there are different components in these cars, right? We all know what all different components we can have: fuel tank, engine, radiator, fan, everything, right? So, and vehicle is driving the chassis, BIW, right? So let's assume this is the temperature values. Our random variables or the possible values are say temperature values. These are the temperature values on x-axis, and on the y-axis it's frequency. So it's pretty clear that lower temperature, say this is starting from 0 degrees say till 200 degrees. Okay, so if I have a car with most of the components with 0 degree, then you can understand what will happen with the car, right? And If I have a car with most of the components at 200 degrees, like the engine does have somewhere around 130 or 110, so you can understand what will happen to the car, right? So it's important that it will be in somewhere in the ambient temperature. You all understand ambient temperature? Ambient temperature is the air temperature, right? Outside air temperature, right? So most of the components in the vehicle would be near to the ambient temperature. So that's the reason in this average temperature, which would be the ambient temperature, near to the ambient temperature, there will be a lot of components which are falling, and that's the reason we have high frequency here. So that's the simple logic about normal distribution, and that's the reason you are seeing the mean value here. This is important, guys. Did you understand normal distribution? Can everyone please write yes or no at least? Because normal distribution is the basis of machine learning. All we have to always check the data whether it is normal or not. Okay, so this is the first step. Whenever you get the data set, you should always check whether the data is normal or not.